Alrighty, thank you all very much for keeping our coffee break relatively on time. I think I'm using the word relatively generously, it sounds like. I am very excited to introduce our next presenter. Amit Kapoor is the co-founder of First Line Technology, which designs and manufactures disaster preparedness and response equipment. First Line has provided products for the Department of Defense and Homeland Security, and Amit is an expert in textiles, dry decontamination, disaster preparedness, and according to his bio on First Line website, also an expert in wines. I hope you aren't necessarily combining any of those passions, but I'm looking forward to the presentation. Thank you, Amit.
So thanks, Josh, for the intro. And yes, I do love wine. So this evening, I can have quite a bit. I'm from the DC area here. I'm going to talk about First Line Technology briefly, my first couple of slides, and then I'm going to go into our technology, and we've briefly talked about it this morning, phase change materials, and how we're incorporating into cooling technologies for our end users, the military, first responders, and others that we work with. First Line Technology, we're based out of Washington, D.C. area, Northern Virginia, exactly, right next to Dulles Airport. The runway is right behind our office, scary at times. And we look at ourselves, and we're a small business, and we take products from lab to life-saving. So our niche is licensing IP, internally developing IP, and bringing different technologies together for the warfighter. And we started in 2003 developing products for Department of Defense relating to chemical biological warfare. At that time, big buzzword was WMD, right? And so we were working heavily on chemical reactive technologies to defeat sarin, VX, our foes, when they were bringing us chemical warfare agents out overseas. We have developed our own intellectual property. We build a couple of different products in-house. We are a manufacturer in Chantilly, one of the most expensive manufacturing areas you could possibly have. But the reason why we're here is because our clients are here. So we work heavily with the intelligence agencies, and FBI, Department of Justice, a number of response agencies, the people who keep us safe. And also working with regulation, and within industry, regulation is either your friend or is your enemy. And so we like to work with the Hill, educating a number of the staffers up there on what we are developing and what would make it easier for us to transition technology out of the lab and actually commercialize it, right? I mean, that's really what is the biggest challenge. When we bring all these technologies out, and they were talking about this morning, you're manufacturing, you're building all these one-offs. Well, how are you going to scale it? And researchers and PhDs are very good at developing products. And the biggest challenge I have is they're so passionate on the university side to say, I have this technology and I want to bring it out. It's like, okay, you built it into the lab. Can you actually commercialize it? Can you actually take it to the next level without it costing $1,000, $2,000, $10,000, and make it commercially viable? That's one of the biggest challenges, and I think First Line prides itself in being able to successfully do that. This is one of our customers, and Globe. They work with firefighters. We'll be at the FDIC conference, the Fire Department Instructors Conference next week as well. Heat. One of the biggest challenges our firefighters and our warfighters face. They work in extreme environments to keep us safe, and not only firefighters, but there's industrial applications as well. One of our customers is Hershey Chocolate. We sell to them because inside of these chocolate factories, it's very hot environments to keep the chocolate at a tempered position. SWAT teams. This is at Putnam County Sheriff's Department, and they're a tactical response team. Their job is to, at times, sit on rooftops for not only hours, but days on end to watch and monitor, whatever the threat might be. Might be a meth lab, might be, some intelligence that they've received, or it might be just they're after a criminal. And so they're in a lot of that gear. And you're talking, the next generation Talus, I think, is the next generation body armor that the soft community is bringing out. Well, look at all the equipment they're wearing, helmets, all the tactical gear, body armor, even the K9 that they have there as well. They're wearing body armor as well. And so heat is one of the biggest issues going forward for the community. We have a technology that we brought out. It was actually developed at MIT back in the late 70s. It's a sodium sulfate. It's a salt. And it's a very unique salt that absorbs heat, and the byproduct of that absorption is a cooling effect. And the cooling effect that we work with is at 72 degrees. We're not cooling the body or cooling whatever we're cooling down is. We're not cooling it down to like 50 degrees or 40 degrees. We're trying to keep the temperature in the 70s on the body itself. And from testing that we've done, we've seen that if we can keep the temperature of the skin surface and whatever encapsulated environment there might be in the 70s, we're going to be able to keep the body core temperature steady and not rise at a very fast pace. It's very different than a lot of other technologies that they overcool the body down. A lot of people have thought, well, if I want to get cold, I'm actually going to take ice and I'm going to put it against my body. Well, physiologically, what happens is your body is going to start heat itself back up. If you go step outside, it's April, but it's still pretty chilly outside. If you go outside right now, your body is going to start to try to warm itself up, and internally your core starts to generate more energy. And people who wear ice vests or ice garments, they'll say, why am I hotter now than I was now I'm hotter after 45 minutes wearing it? It's because their body has heated itself up and try to generate more heat inside the core. Our technology is also very simple to use. So fire departments, tactical teams, they already have complicated night vision goggles, complicated helmets, complicated weapons. Well, the garments need to be very easy to use. That's why Globe is revolutionizing the garments that the first responders wear, because it's got to be so simple to put on and work every time. So it's heat activated. There's no power. There's no switches. And I have a sample of one of the packs that actually encapsulates the sodium sulfate. So this is about 83 grams of sodium sulfate inside here. And this packet here actually will absorb heat, and the chemical reaction will cause the cooling to occur inside the vests. And I have a couple people wearing vests in the audience right now. I have Ryan over here on my left who's wearing it. And the technology, we put it inside of a carrier, and that's the vest. And I'll talk about what we've learned over time in terms of transitioning, going from the military market for responder to the commercial market now into sports. The technology also, it recharges without ice or refrigeration. So like I said, simple to use. If you leave your cooling vest in a locker, you're going to forget it every time to go out to the fire, because you're jumping into your fire rig and getting down the fire as fast as possible. You need something that you can carry in your locker, whatever it might be. So I'm talking about phase core 28, and 28 stands for 28 Celsius. So the chemical formulation that was generated by MIT allowed for tailoring the sodium sulfate to be activated and provide cooling at certain temperature levels. So phase core 28, we have also a 32 degree Celsius. We also have 48 degrees and 58 degrees for higher temperature profiles. Phase change is not a new concept. It's not a new technology. The method of how you deliver phase change is what's unique, and how you can encapsulate that inside of fibers, if you can do hollow fibers, or how you're going to be able to encapsulate that into packets for quicker delivery to your customer base. Bless you. What we needed to do was, ice is a very common phase change material that you put against. You could put that against the body, but again, you're delivering too cold of a material, and we needed something that would be very easy to put into pockets inside the vest and activate at 82 degrees Fahrenheit. And the skin temperature is about 84, 86 degrees, your skin. And when your core temperature rises, the blood will start to circulate a lot faster. It'll start to push out the heat to the skin. What you're trying to do is absorb that heat as fast as possible and cool the body down. The cooling we're providing with the PhaseCore 28 is 72 degrees Fahrenheit, and that's the optimal temperature that we found. We've done numerous tests with PhaseCore 32, but cooling at 82 degrees wasn't comfortable for a lot of the wearers. Mainly, physiologically, it worked a lot better, but mentally, they were not prepared for 82. They were like, I'm still warm. And it was that balance of consumer level, what is the user going to accept as the cooling temperature against their skin? They still want to be able to feel a little cool, even though they are still being protected from the heat. And it was a balance that we had to find. We needed something that would be effective for hours of use. So like I said, that tactical team is on the rooftop for hours at a time. So they needed something that they could utilize and be up in the rooftop in high temperatures for 8, 12 hours with the same vest or replacing out pockets in the vest. Can't use ice. We don't want to restrict the blood flow. When you put ice against the body again, it will restrict the blood capillaries on your skin and will actually slow down the flow of blood through the body. And so you're losing that heat transfer mechanism that your body naturally has. So we wanted to have a better optimal temperature for mental and physical performance. Then it came down to fabrics, right? So we're here for smart fabrics, but we were looking at what kind of fabrics are we going to be able to push out to the user-based community that's made in the U.S. I'm the president of First Line, and I made a mandate in 2003 when we first started the company that we had to have a yearly audit of 96% of our materials had to be not just made in the U.S., because that's easy, as difficult as that is. I'm talking about sourced from the U.S. So we're talking to go back to the thread, to the dye, and I just talked to a company outside. And my first question was, and I blanket, are you Berry Amendment compliant? And that's the easy, can you deliver a product that's made in the U.S.? Mainly because for us, we have tried the manufacturing overseas base, and it hasn't worked for us because, again, our community is the military. They want the highest quality, and they're always changing the deliverables. Even the requirements in a global scale don't change because cooling is cooling. They want to change the color. They want to change the pattern in a certain form. So if we're going to be manufacturing somewhere else, first of all, you can't sell to the military. But even on the first responder side, it was too difficult for us to buy 1,000, 2,000. We needed the one-offs. I think I talked about one of our customers is the intelligence arena, and they're always on a mission constantly. Every couple weeks, they'll be coming into our office and say, we need to have a custom design cooling panel to go underneath our new body armor, because they're always getting the latest and newest technologies to fight the battle overseas. We needed that one-off capability, and that's what we're doing now in the U.S. Our cut and sews in the U.S., we're sourcing fabrics in the U.S., the dyes. It's something that we take back and we take some pride in. So as we've gone along with the phase-changing technology and the PhaseCore product line for cooling, we've had to make multiple fabric choices going into the future, mainly because the first product, again, the technology is the cooling. Our vest was horrible. I mean, our first generation of cooling vests, and I think we can all say this about our first prototype beta test, it just looked horrendous. However, we did sell a lot of them to the military because they didn't really care about what it looked like. They needed the functionality of the product. And that's great to get, to solve a solution for cooling. But when you try to move into the first responder market, move into other commercial markets, sports market, they're looking for the sexy look. They want the look of the product. You got the function, but the look has to be there as well. Also, the customer demand of, I have a vest up here, high visibility. So we deliver a vest to Amtrak, for example, or even the WMATA, the metro lines here. You have industrial workers who have to wear high visibility vests. And we forget about them because they're out in the traffic area and they're working in high heat, even though we're in our air-conditioned cars. And so that was an application we had to follow ANSI standards, and it was a big challenge because we had to be able to meet the ANSI standards, compete with Chinese-made or overseas-made not cooling vests, but just ANSI vests that are $5, $10. Apply a cooling technology into it because our industrial partners, Amtrak and everything else, they were looking for worker safety, heat. Even in Cotter, we've heard the press stories over the past couple of years. In Cotter, they're putting up massive buildings overseas in the Middle East, Saudi Arabia, and we have now transitioned over into delivering them U.S.-made products in the Middle East because they're looking for industrial safety. They got a lot of bad press, looking for worker safety, and that's where the high visibility have come out, our vest. FR protection for fire resistant, fire retardant, whatever it might be. Finding U.S. partners to work with, there's DuPont and there's other manufacturers as well who have come out with unique and novel ways to deliver FR properties to cooling vests, and that's what we've been able to apply into our vest. As well as colors on demand. And I talk about this going into now the commercial realm, sports realm. Customers want the unique color, the Nike ID or whatever it might be. You customize your footwear, customize your clothing, and they want a fast turnaround. So we've been able to now deliver a unique fabric with the colors that they want and a pattern that they want as well. Our fabrics utilize a 3D spacer. Air is the best cooling mechanism out there. So we want to utilize air within a 3D fabric. So as you move, as you flex, and you become underneath a turnout gear, whatever it might be, the air will actually float around the phase core packs that's putting off the cooling to cool you down even at a faster pace. And machine washability, we needed to be able to have easy to use, easy to maintain. We've been looking at antimicrobial, antibacterial coatings or technologies. If you have any, we are very interested in it. Please contact us because machine washable is a massive challenge to our user base. Our soft community, our military community, they're out there in the desert or wherever they might be for days on. They don't have washing machines. They don't have laundry. So they need to have their clothing to be able to be utilized and not deteriorate and just honestly smell while they're out there in the field. So that's what we're trying to push out into the community. Just talking about the differences in phase core, and this is like a graph about how the technology works. The upper red line is a user wearing no vest. The ice vest where it has this yellow gold line at the bottom, and our phase core vest is in the middle. So just how the technology functions. There is a cold hazard. There is a heat hazard to the environment. There is also a cold hazard. So if I overcool the body down, I'm actually, and I've talked about the issues you have, we want to keep the body temperature actually within this heat hazard to cold hazard range for a prolonged period of time. If I want to just do this for 45 minutes or 15 minutes, that's easy. What's the challenge is, can I do this for 2 hours? And that's what the phase core technology allows you to do. When you're running a marathon, you're running a track, you're running a 5K, whatever it might be, you need that prolonged period of time of cooling and keeping the body comfortable. This is another picture we've taken with a FLIR camera of a user wearing no cooling vest for before. You can see the heat patterns up in the other chest area. So when they put a vest on, it has these pockets that hold these elements in it. And you can see from the infrared camera that it starts to cool down and the temperature starts to change and allows the actual core that we're trying to tackle start to cool down and to maintain its temperature. Here's the different styles of vests that we've created, and I can kind of run through how this transitioned. We came up with a Swede cooling vest. That was our first generation. It holds 22 packets, 22 of these 83 gram packages in there. It was our first vest, and we made 4 different sizes to go for firefighters, and it has shoulders that has padding on it. And the fabric was just straight polyester. Over time, our users start to come back and say, it doesn't cool enough. We need to have better accessibility inside the packets to pull them out of the vest itself. And we need something that can fit one size fits, I'm not going to say all, but one size fits most. And so we designed a standard cooling vest that was a basically a one-size-fits-most deal. It has 16 pockets, easy to put on, easy to take off. Recently, we've come back, budgets have declined within the military and the first responder market, but sports has become huge. I mean, there was just an article that running is now a huge, huge push with millennials. And so we were like, wow, this is the great avenue for us to tackle, but we need a vest that looks and has that feel that the millennials want to buy. And we came up with the XPC cooling vest. And it has the benefit of more cooling against the body, so 21 packs. But we got away from Velcro. We worked with more zippers, locking zippers, and designing it so it has more of a touch feel of a fashion. First Line is not a fashion company at all. We know the last thing about fashion. So we had to work with customers and consumers to give us the ugly news, not the bad news, about why our vests were horrible. What did not look right? Black, white, gray. What colors would be, what were they going to be happy with? And so it was a great medium, and it was a great focus group to kind of push out cooling vests, push out vests into the market. The medical market is a great market to go after, especially for cooling. We sell a lot of vests to the MS community for MS patients. Their body have a difficult time controlling temperature. And they also like to give feedback about why your products don't work or why your products are not for them. And a lot of them are bound by wheelchairs, or they have to go through things you don't think about. They have to go through TSA, right? They're traveling. So they're traveling abroad. They're traveling internationally. They need a product that TSA is not going to stop them at the airport. So that's where the XPC vest came out, and we've designed it. And we've gotten great user acceptance and user base. And we're looking at new avenues to push the packets out to the phase core technology out inside of other garments that might be out there available. Here's a high visibility, more of a closer shot when I was talking about Class 2 compliant was a challenge for us to meet, mainly because when you add 20 packs of 83 grams each, you're adding a lot of weight to the vest. So when you have a breakaway vest and you're doing work, your vest wants to just break away automatically while you're doing a lot of work. So we had to work on the Velcro. Was that going to be the best mechanism and still meet the breakaway standard that ANSI asked for within the vest itself? We are also developing using phase core other products. So we have helmet liners, hat liners, horse leg wraps. Very new market for us. This came out. Horse racing, huge market where horses overheat after races. So their legs and their ankles need to be cooled down and rehabilitated. Laptop coolers. Everybody has laptops or iPads, whatever it might be. I have a Surface. My Surface loves to overheat constantly in my laptop bag for some reason. So we developed a laptop cooler that you can throw into your bag that can keep it. You can keep your laptop bag inside of your vehicle and have your laptop in there and still will maintain a certain temperature to keep your laptop safe. Overheating is bad for your laptop as well. And calf sports for rehabilitation. Calves, your quads, rehabilitation using cooling there. So evaluation of users, I just go into, who is our user base and who has been using our technology. Like I said, we've been working heavily with the U.S. military and in the past. So the Joint Science Technology Office, JPO, that's the Joint Program Executive Office. Soldier survivability, they have a mandate for finding mechanisms of cooling down soldiers. Lots of testing overseas and thousands of deployments within the U.S. and international markets. The international market is a massive market that we've now dipped into. Australia is a big buyer of our cooling vests and just our general products. The South American market, the Middle East loves American-made products. When I go there and I talk about it's American-made and it's American sourced, they've been burned by international competitors, be it Taiwanese, be it whatever company it might be. They've been burned by products that don't function, that the one-off prototype that they brought was fantastic, but it didn't prove to be successful for them. Developments and deployments we're looking to do is we're adding heat. One of the biggest, we have customers come to us and say, hey, you can cool, can you now heat? So we're looking at technology that can heat into the fabric itself. Better FR fabrics, better fabric designs for moisture wicking away, and then maybe transforming our phase core technology from salt to a fatty acid. And we're looking at new mechanisms of cooling delivery to bring the cost down. I want to talk a little bit about the integrated low voltage heating real quick. So we're working with a company right now, Lumina Heat. We're not bound by one company. We're just looking at technologies out there. Because again, just a globe, we're looking for best industrial partner out there. They make a power fabric. So it's like resistance heating, right? So common in your car, vehicle, if you have heated seats. So resistant, low voltage through the fabric to actually heat the fabric down and allow it to heat the body. So different temperature profiles can be done with it, and very quickly they put into flooring comfort. We're looking at personal comfort, vehicles. De-icing is one of the biggest applications of this fabric, and we're trying to bring it down to clothing. Huge challenge. Talk about laundering, but we're talking about not reacting. This heat can't react with electronic equipment that soldiers are already wearing or firefighters are already wearing. They're wearing a lot of electronics, and their electronic packages are growing at a faster pace than their clothing packages. So we have to be able to accommodate those systems. The way that technology is going to work, and this is common, it's a resistance. So you have it's a carbon fabric that's sandwiched in between and laminated onto a polyester. Then we just have a positive, negative, low voltage that we're able to then take the conductivity of the heat that's generated and put it against the vest. We need a fabric that can integrate with our current formats of how we develop our vests. And that's been one of the challenges we're looking for. And we're looking for industrial partners out there to help us take it to the next level as well. That is my talk about the technology we have for phase core. And I have a number of vests that people can try on. I'm going to be here until the evening, and Steve is here as well. On the side here, we have, I think, 10 vests to try on and to evaluate to see how it works. And we have a bunch of packets here as well. So I can take some questions if anybody has any. Or yeah.
Quick question, thank you for the presentation. I think it's a great story about manufacturing. One of the applications that you talked about for the phase core is the industrial applications, as well as using transportation for workers who are in areas. One of the benefits there is increasing productivity for staff who are wearing the vests.
Yep. Yeah, that's a great question. So we had done this with the military, where we had worked with them in the past of how, as troops are out there, can they recover faster? We just did a test, Hershey Chocolate, we did work with them on, they take a lot of breaks throughout the day, just for OSHA regulation. So they're going in, they're working for an hour and a half in a high heat environment, coming out and taking another hour and a half break. Worker productivity is a challenge for them because that's dollars to them. So we're able to cut that down, actually sort of their recovery time. If they're wearing the vest while they're in the high heat applications, they can recover at half the amount of time. So rather than an hour and a half break, they're taking half an hour to 45 minutes break. And they're able to recover faster and just get back into the field a lot faster. So the money side of that, Saudi Aramco is another client that we presented this to. Saudi Aramco out on the oil fields in Saudi Arabia and all the other platforms they have, their savings on a yearly basis was about $12 million of worker productivity savings that they were going to have out of this.
When you see material, usually when you see it has a temperature range, when it works, it either goes cooling and then drops down. So with the phase core, do you have a range? I mean, you said 72 degree Fahrenheit, but is there a range in which it works?
Sure. So the technology works between 69, so the cooling temperature is between 69 to 74 degrees of temperature. That will provide a cooling. The absorption rate where it clicks on to start working is between 80 to 84 degrees. So there's a plus minus. The range, so the maximum you can take the heat for a prolonged period of time, have heat exposure before the salt starts to deteriorate, is about 160 degrees Fahrenheit at a prolonged period of 18 hours or more. So that's when it starts to deteriorate the heating, the cooling property of it. Yeah.
Great. I mean, thank you so
Sure.
much. I really appreciate it. Really fantastic presentation.
Thank you.
Awesome. Amit, thanks so much. Hopefully everybody is excited to try on their cooling vests later in the presentation during the break. It is now my privilege to invite the next panel up to speak. Our moderator is Alan Davidson, the Director of Digital Economy and Senior Advisor to the Secretary of Commerce. Along with him is Dan Cotter, the Acting Director of the First Responder Group and the Science and Technology Directorate at the Department of Homeland Security. We have Dr. Jess Jur, Assistant Professor of Textile Engineering, Chemistry, and Science at North Carolina State University's College of Textiles. And Steve Luckowski is the Program Manager of the Revolutionary Fiber and Textiles Manufacturing Institute at the Department of Defense. And so thank you all for coming to talk about some of the ongoing federal investments in smart fabrics. We have a fantastic story to tell about how we are investing in research dollars here. So I'm going to turn it over to Alan. Thank you.
Thank you, and thank you for that introduction. Thank you to all of you for being here. I'm Alan Davidson. I'm the Director of Digital Economy here at the Department of Commerce, and we are delighted to be hosting this event, and I'm delighted to be up here with a group of people who've been really working in this space for a while. Let me just say a quick word or two. Being the Director of Digital Economy, a lot of people ask sort of what is the Department of Commerce's theory of the case about the digital economy? Why are we engaged in this space? And I will say part of it is definitely a strong sense that the starting point for thinking about the digital economy is the kind of household name internet companies and IT and ICT communications companies that we all know and love. And they are a shining success story for the American economy. The quote-unquote internet economy is already over 5% of GDP and growing here in the US. But that really doesn't tell the whole story. If you look at things like the revolution that's happening in digitization, recent McKinsey study showing that digitization in the economy alone is going to add somewhere north of $2 trillion to our GDP by 2025. And that probably doesn't even fully encompass the kinds of revolutionary trends that we're talking about today. So we are big believers in the transformative power of digital technology and the opportunity that it brings to the U.S. economy. And we're delighted to be here thinking broadly about our agenda to promote innovation and emerging technologies. So this fits very neatly into our broad view of what the department's broad agenda is for thinking about the digital economy and how to support innovation. In that spirit, I'm delighted to be here today for a panel that's focused on how federal research and development dollars can support innovation in smart fabrics. And we have panelists, kind of all-star lineup of panelists within and outside the federal government who've been thinking about this issue. Josh has already introduced them, so I won't do it, and they've got their great bios in your program, so why don't we jump right into it? And I'm just going to ask a set of questions, and then we'll throw it open to all of you as well. But let me start with Steve Luckowski here, Program Manager at DoD for this new Revolutionary Fibers and Textile Institute. So, Steve, maybe you can tell us a little bit about, you were among the leaders at the Defense Department that selected advanced textiles as a theme for this latest institute. And the winner was just announced 2 weeks ago. The Secretary of Defense was up at MIT talking about this consortium. Congratulations on the announcement. I mean, it's over something like on the order of $300 million of federal and private sector investments, $60 million of federal investment, something like that in the mix over the next 5 years. And so I guess maybe you can tell us a little, or can you tell us a little how did DoD identify fibers and textiles in the first place as a potential manufacturing institute? And then maybe you can tell us a little bit of an overview about the institute as it's kind of been rolled out.
Sure, I'd be happy to. In fact, I was a little bit torn because I thought maybe I wouldn't be able to talk about this at all. So it was, with the announcement being...
Our timing was perfect.
It was perfect, exactly. And it's purely coincidental, actually. This event didn't precipitate one or the other. But I'm happy to be able to talk about it today because I was a little bit nervous that I had nothing to talk about. And I was saying to most folks that I was very busy, not able to talk about anything for the last year. So now I have a lot to talk about with a lot of people. So there's probably not enough time today to talk about it, but I'll be available here at breaks and at the reception tonight. But in DoD, we have a process for everything, right? So we have a process to establish the institutes, and this is the sixth of the DoD institutes. As you're probably aware, this started as a challenge by the president back about 5 years ago. The President's Council of Advisors for Science and Technology developed a report that we need to bridge gaps from research and development to productization, and need a healthy ecosystem within the United States for manufacturing. So as a result of that challenge, the Department of Defense raised its hand and said, we'll lead an institute in that vein. And we started with America Makes, which is the Additive Manufacturing Institute in Youngstown, Ohio. And since then, we've launched a number of institutes. And again, Fibers and Textiles is the sixth of those institutes. You're probably aware also that in 2014, the Revitalize American Manufacturing Innovation Act was passed. So the Department of Commerce now has the charge to bring all these institutes together. So we have 8 total now in our network. But as far as Fibers and Textiles goes, the DoD's had a long tradition, and the Secretary, he talked about the long tradition of investment that the Department has made in forward-leaning and forward-looking technologies. And Fibers and Textiles is certainly one of those areas that we've examined thoroughly. Many of you probably participated in workshops and along the way and to help us identify these topic areas, so thank you very much for your input. We looked hard at our portfolios and the investments that we were making within the department and areas of priorities that we could make a difference in terms of the public-private partnership that we envision these institutes to be. So that played into it, certainly, but it was really the contribution of all of you to help us advance this topic. And this is a very exciting area. And I always kind of joke about it. I'm a materials engineer and spent most of my time in metals. So this area is very exciting to me, and I see a lot of analogies with this institute in manufacturing we've seen in other industries that are old industries. Fibers and textiles are one of the oldest industries probably the humankind actually knows. So that was a little bit about our process, and what do we intend? This is a public-private partnership that we'll have with industry through our contract. So again, it's a very exciting time for us in terms of our investment. Probably can talk a little bit later about some of the details, but we're excited to launch the institute, and we'll talk about it further.
Well, just even to follow up a little bit, do you have a sort of, is there a near-term kind of roadmap of
Yes.
projects that are coming out? Or?
Yeah, so actually, we have a schedule. It's a 5-year program plus 6 months of stand-up. So as far as project goes, I mean, we'll be developing projects in the institute. So these institutes generally are member-based organizations. So everyone will have the opportunity to become a member. We expect in the near term, I hope within the next 2 to 3 months, to have prospective members meetings. Of course, there's a whole proposal team that developed a proposal and has been awarded this contract, and they have a membership that's been defined, but the membership is much broader than that. I mean, there are a lot of folks here I know that want to participate. So our plan is, right now you can look at AFOA.org. This is a team that's led by a nonprofit called AFOA, Advanced Functional Fabrics of America, which is a team led by MIT. But again, like I always try to say with this, everyone's a winner in these institutes. One organization has the opportunity to lead, but your opportunity to participate is what we're really looking forward to. So this is a very unique membership model, and I won't go into all the details about the membership model, but I think it's very attractive to both large and small companies. It has something that's called the Fiber Innovation Network, which is actually based entirely on cost share. So we're looking to build a collaborative infrastructure in both prototyping and pilot facilities for fiber and textiles. So if you're a small company and you don't have a lot of cash, that's not a basis for membership in this institute model. Another thing that we've done through our contracting vehicle, this is unique in the other institutes. We've chosen what's called a technology investment agreement, which is different than the other institutes in terms of the contract vehicle, which gives us a better ability to negotiate in terms of intellectual property, which is very, very attractive to industry. So I think you'll find this model is for us it's exciting, it's new. Even though we have 5 others, they're all a little bit different, and I'm certainly looking forward to managing this one, and more to come.
Well, as a former MIT guy, I have to say I congratulate you on your choice of leadership. But no, I'm glad, and as we know, these are broad efforts. Let me turn to Dr. Jess Jur. Jess, I know the National Science Foundation is funding some of the research that your folks are conducting at the Assist Center. I'm going to get the acronym wrong. I think I've got it. It's the Center, the Advanced Self-Powered Systems of Integrated Sensors and Technologies. Did I get that right? All right. Well, I read it right anyway. So, right. But tell us, you guys have been developing some unique partnerships yourself. Can you tell us a little bit more about the center, the industry partnerships that you've formed so far, and how your own particular work on energy harvesting and other areas kind of fits into it?
Yeah, absolutely. So I guess I'm the person on the stage that doesn't give out money, but I'm happy to receive it. Anyway,
you're in a good spot then.
Yeah, exactly. All right. So yeah, as you mentioned, I'm part of the Assist Center. Assist is a nanosystems engineering research center that was funded in 2012. So engineering research centers have been a vehicle for the National Science Foundation for a number of years now. I think they're in their either 3rd or 4th generation of ERCs, where it's meant to establish relationships between industry and academia. It's also supposed to establish relationships between academics, which is actually is even a tougher thing sometimes. So in ERC, it's really kind of founded on a 3-plane diagram. So if you can imagine these multiple planes of research levels from a fundamental research base, which is what NSF is really known for, going all the way up to almost like a product realization and putting those products into a clinical setting. So we have these test beds up at the top level of this 3-plane diagram, and as you go down, you have integration, then you have fundamental research. So we do our fundamental research in developing self-powered wearable electronics. We have test beds that are patches. We have test beds that are wristbands that go towards a directed health outcome. And so we're developing these systems, and we, from a textiles perspective, this is what I actually lead. So I'm a thrust leader for wearability and data. So I manage how different types of sensors or different types of energy harvesting devices will get integrated into garments. Then we place those garments onto humans. We do human trial testings with those in clinical settings, and then we, with the advisement of a medical advisory board. So we have partner institutions at Michigan, UNC Chapel Hill, which is tough for me because I'm at NC State, but they're the closest hospital. And then we also have University of Virginia, Penn State, and Florida International University, our partner institutions. So we do research on, again, developing new technologies for energy harvesting from the body. We do new technologies associated with sensors. So we have environmental sensors that might be applicable to evaluating a human's physiological state or things that affect the human's physiological state. Then we also work on sensors that monitor biochemical fluids that are coming from your body, as well as bioelectronic signals. And then, of course, on the real hardcore electronic side, we do a lot of work on low power electronics, so low power communications, and then also the just really ultra low power electronics that are basically like you see the Arduino lily pads or Arduino boards. We're operating those devices instead of at milliwatts of power, we're operating those devices at like tens of microwatts of power, which really starts to enable you to be able to power that with your human body.
Interesting. So you do a lot of work on health-related systems. How big an issue is safety? Is that something you hear about a lot from people who are involved, or how do you guys approach that?
Yeah, so there's a lot of ways in which you can look at safety from a biocompatibility standpoint, and then all the way up to data security. And then, so what we do is we actually go out and survey populations just as any startup company would. We survey the populations to understand what are the challenges that certain sections of the population are feeling that might affect their device being incorporated with them. Of course, this is actually one of the main challenges for any wearable device that you're going to end up making, whether it be on a garment or outside of that, is understanding what is the market influences and what are the market influences that will end up affecting whether or not a person's going to want to even buy this. And so we do a lot of human surveys and that's kind of establishing these networks of people that we can go out and survey. So somebody was mentioning earlier, the participant from Hawaii was mentioning, where do we have these databases where we can just have survey 1,000 people? And that's one of the things that you literally have to create sometimes from the ground up. And it's not necessarily an easy thing to do. And we have researchers that reach out and do those types of activities.
Thanks. Why don't we turn to our last panelist, Daniel Cotter from DHS, former CTO at DHS. Is that right? Is that correct? So now you're within the APEX program within the Science and Technology Directorate, which was, as I understand it, recently founded as part of this longer-term commitment to envision with to assist the responder of the future, right? So maybe can you describe a little of your vision for the next generation first responder group and what that vision of what the responder of the future looks like?
Sure. Yeah, so I'm with the first responders group at DHS Science Technology, and our job is to support the first responder, particularly looking at the state and local level first responders. I don't know how many of you here might be first responders doing the evening shift at the fire department or part-time EMT paramedic. Thank you for what you do. So a big part of our job is how do we keep you safe when you're doing your job? Unless we can keep you safe when you're doing your job, you can't keep us safe, you can't help us. It's a big focus of our research. Everything we're talking about today is a big element of that. The second thing we really look at then is also how can we help the first responder be safer and more efficient? And we were looking around at our technologies, what we do, and really about a year ago, we kind of sat down and said, we can work on particular aspects of it, better radio, something like that. But what we really need to do is start thinking about this in more of a systems approach. So the idea of a next generation first responder vision around the idea that the first responder should be protected against the hazard he faces. So the personal protective equipment that he wears, the garments, the fabrics that are engaged. Some discussion about microbial, bacterial, things like that. But for the firefighter, also all the cancerous materials in the smoke themselves, all those types of things. How can those fabrics also be decontaminated easily? Bill Disso's here with us in the back. He's one of our materials scientists working on these projects. Connected, wherever you are, always being in touch with your team, with your command posts. So in a building, underground, in a parking lot, in the middle of a wildland fire somewhere, in the Arctic. I think one of the big cruise lines is scheduling its first Northwest Passage tour. Imagine the problem doing mass search and rescue in the Arctic. The environment, the temperatures, all kinds of issues with communications up there. Fully aware. Does the first responder have the information they need when they need it? We do a lot of great work. We talk a lot about big data analytics and all the things coming out of IoT and smart cities. How do we get the piece of information to the first responder on time so they can make a difference? And that's one of our real big challenges. And I think it all rolls up into aspects we're looking at of how we build base duty uniforms. What do we think the future is of sensors on the body of the first responder, not just for their physiology, but also understand the hazard environment that they're operating within. And how do we work this all together in a communications package that's interoperable and intuitive for the first responder? It doesn't have to do a lot of new stuff. It doesn't have to touch a lot of new devices. So some of those challenges that we're looking at today.
Do you see examples of this already out there in the field today? Are there
Sure, yeah, there's things evolving. Certainly some of the folks we have here demonstrating today, BearTech is one of the group, for example, that we worked with in the past. There's certainly a lot happening, in this space. I think it offers, a great deal of promise. A lot of challenges remain, particularly the issue of washable came up before. Think of the firefighter wanting to power wash his duty uniform after coming back from a particularly egregious smoke-filled environment. How do you make that happen and have these things survive? So a lot of research challenges remain.
A couple of questions for the group, and then we'll throw it open to your questions out in the audience. It's clear that there's a huge amount of research and development already going on, and this is kind of a whole of government approach. That's, I think, something we're demonstrating nicely here today. What are some of the ways that the private sector can tap into these resources? Either to license technology that's already been developed, or to seek out assistance in developing a new idea, or be involved in some of these consortia. Yeah.
The way DHS, we typically work in this area is we bring together practitioners group. We have something we call the First Responder Resource Group. And after they meet, working with them, the stakeholders, we don't own the mission, the first responders do, to understand what they need. Those capability gaps that are described to us from those communities actually result in us then putting out broad agency announcements, which is how we typically procure things. I think the smart fabric, the e-fabric world, those really going to have us going in a different direction in the upcoming years. In the past, maybe it was all about a better duty uniform or ensemble, things like that. I think in the future, when we think about fabrics and we put out broad agency announcements, we're actually going to be talking about them in ways that we're going to be asking people to think about them as a technology platform. So in effect, you have the computers, the computing power, the sensors. How's that all work together? What does that architecture look like? What are the industry standards that we need? How does it connect to the bodies out there that are working things today, like the Internet of Things or smart cities that the responder needs to connect to as well?
Yeah, so from the assist side of things and from the NSF, so these ERCs, they do have a membership agreements that can be established with industry, just like the MII is going to have. And so we work with companies to, they help direct, basically as members, they get to help direct where the technology is going, whether or not it's relevant for them, and they get to help judge some of or they get to help rate some of the proposals that we have coming in that end up getting funded through the NSF funds, and then some of their internal funds. And then they also have first rights of refusal for licensing some of the technology that we have coming out. So there are avenues for that, and ERCs as well as the manufacturing institutes. They have specific guidelines on how, each one can be very different on how the technology can be licensed out. But in general, and it always ends up starting out with like an IP understanding between a faculty member or that institute and the company. And then once that's established, then they can start going out and saying, okay, we want to try to look at this technology. Then we can go out and start applying for other federal funds like SBIRs or STTR funds to help develop that technology further.
Yeah, I guess I talked about it, but I can expand upon it. In terms of working with the Institute, obviously, after the stand-up phase when we get up and running, there'll be a lot of opportunities to work within the Institute, obviously, as members. As I indicated, cost share is a key aspect of working with the Institute, so whether it's in-kind or cash, that's a key attribute of working with the federal investment. The federal government is making a $75 million investment. And we'll be developing projects within the Institute. So your participation in the Institute helps us roadmap the technology thrusts that we want to examine the gaps. So we'll have a technology advisory council in which industry and academic organizations that are members of the Institute can participate in those councils to conduct road mapping exercises. Once we develop the gaps, we'll be developing projects along those gaps. And so if you're working within the Institute, you'll have the opportunity as part of that Technology Advisory Council to map the path for projects and develop project concepts. And there'll be an ability to down-select projects through the Institute for your execution. There'll also be a number of other councils, workforce development councils, economic impact councils, and other areas where you can participate given your interest in terms of activities with the Institute. As a resource, the Institute will have capabilities, and we'll be developing capabilities in modeling, simulation, and design. So we believe that that'll be a resource that industry will want to use. That'll be available to you when you participate with the Institute. So I think that's kind of the next wave of where I think this technology needs to go, like I alluded to earlier with other manufacturing processes. Modeling and simulation is a key aspect to making it more available and more affordable. So I think that'll be a resource for you to use. And you can use that within the projects of the Institute with cost share or fee for service. And we'll also be looking to bring in other customers. I know that the Army will be a main customer of the Institute, so we'll be executing work in our manufacturing technology programs of the Institute. I also see programs like small business innovative research programs or other programs within the government as being launching points for activities within the Institute to develop that catalog of technologies that we can mature and make affordable through manufacturing. So I think there'll be a number of ways that you'll be able to work within the Institute from an industry perspective.
So as I said there before, there's clearly a huge amount of R&D going into smart fabric space. You folks are on the front lines of that. I'm kind of curious, what do you think are the most important research gaps right now that need to be filled if we're going to really make products that work for first responders, for soldiers, for consumers and businesses? Where do you see the big holes right now, and the biggest areas that need work?
Sure, I'll take that. All right, so I study this quite a bit, right? So just because, I'm coming from the electronics industry, so I did my PhD research in high-K metal gate, and who knows what high-K metal gate is? All right, like one person. All right, so that's how you make transistors.
Might have been one
All
and a
right,
half.
so and then I got into textiles like about 6 or 7 years ago, and doing advanced coatings onto textiles, and it was once I started to talk to textiles companies, they said, is this a realistic avenue, or is it really manufacturable? It really kind of started to generate a lot of questions in my head. So what I've learned out of this is that you really have to develop this, and I know that we've talked about this a couple times already, is the supply chain ecosystem surrounding all the different components of the technology that's going to go in. Otherwise, you're going to there's big differences in between a horizontal supply chain and a vertical supply chain. And vertical supply chains is what 99.99% of these companies that are making anything electronic garment based are doing. And that just is not a very economical approach. So they may feed in a couple technologies here and there, like a conductive yarn or a conductive ink into it, but it's not really a full-fledged supply chain at this point. So what I do specifically in my research is I look at alternative supply chains, like in the print electronics industry, and seeing how those types of technologies are developing, as well as other like energy harvesting technologies, and how those supply chains are developing, so that I can see intersection points that really kind of make sense within a 2-year, 5-year, and 10-year timeframes. Again, looking at the supply chain is, I think, one of the most critical things.
I think for me, looking at where we are at the first responder community, we've got a lot of stuff on kind of the lab bench, that works, and you can kind of see the future where it's going to get a lot smaller and not need as much power. You can really see it being incorporated in some type of e-fabric or smart fabric. The piece I struggle with is understanding how it's going to survive in some of the environments the first responders in. How it's going to stand up to the heat of the firefighter environment, some of those other environments that they work in every day, and be repeatedly washed, repeatedly abused.
Yeah, to that point, so I know we're going to talk about standards later on, but understanding the scenarios of use for those and just doing like a risk assessment, which I hope is a word that we're going to hear a little bit later on quite a bit. Understanding the risk assessment for those types of activities or any other types of activities that your product is being defined for really needs to be, those criteria need to be set initially before you even start sewing anything together.
Steve, anything to add?
The only thing I can add is that's great input for our road mapping. So I'm looking forward to you guys and others participating. That's the kind of thought leadership we're looking for in terms of our federal investments. So, I'd really can't comment on what we've developed in the Institute in terms of our gaps. But certainly from, if I look at it from the Army standpoint, I mean, our vision is we'd like to see soldiers have, the capability to have mass customizable uniforms, a uniform that fits, that can take them anywhere in the world, and they can have the camouflage that's adaptable, they can have the power they need, they can have the protection they need, all out of the fiber. So I think that when you look at fiber and electronic devices and the capability that can really be provided, whether it's a wearable technology or it's our shelters with insulation, there's so much opportunity in this technology space. So we're looking forward to the mapping. It's not just a DoD thing. I mean, I want to make that clear that although it's DoD-led, I mean, I think that, there's not a lot of difference in my mind between a soldier and an Olympic athlete or a high-performance athlete. So I think that there's a great crossover, and from a DoD perspective, we're very tired of building supply chains that we're the only customer for. So we really want to have a partnership with industry so we can share that, we can have a healthy ecosystem and a robust supply chain that we can use. And I think this technology is really the crucible for that.
Why don't we try to open it up for questions from the audience? We've got a mic up here and a floating mic in the back. Any takers right now? There's one in the back over there.
Stephen, could you elaborate some more about membership and how to become a member?
Right now, all I can tell you is look at afoa.org is the website, and you can get more information there. Since we're in the stand-up phase, we don't have a clear path for membership yet. Like I mentioned, we plan on having a membership meeting at some point for prospective members. Clearly, there was a proposal team that had a membership structure developed, but within the next few months, I anticipate that we'll have a prospective members meeting where it'll be more clear in terms of membership. There's a lot of work to be done in terms of the Institute in developing and finalizing membership agreements so they can be publicized for folks. So I would say we're still at least 30 to 60 days away from having a lot more information. But if you want to check out the website, that's certainly where you can get more information on AFOA, Advanced Functional Fabrics of America, and their plans. And I'll be working with them to make those plans known to the widest community possible.
Other questions? I've got plenty, but yeah, one right up here.
Jess, we heard earlier that one of the big challenges for manufacturing these products is power. Can you talk a little about your research in the energy and power space? You mentioned self-generated power. Without too much into the science of it, how would something like that work, and how far are we incorporating some of that into products?
Okay, absolutely. So there's three general types of ways in which you can harvest power from your body. One is based on your thermal heat that's given off of your body, and the other one's based on kinetic motion. There's multiple ways from kinetic motion that you can harvest power. So I like to look at thermal energy harvesting just because I think that technology is kind of tracking out a little bit better than the mechanical or than piezoelectric energy harvesting. And that's where you are getting the mechanical resonance from the human body, or you're looking at joint movements to generate power. So with the advent of Bluetooth, and then especially the Bluetooth Low Energy, you can start to get devices, or you can start communicating data away from devices at really low powers. And so that's going to be your data communications is like your biggest power consumption component within any wearable device. Sensors can be adjusted, but it's really how you send the data off. And of course, the data is your most important aspect of whatever wearable that you're going to make. Is 90% of the value is going to be in data. So you got to push that data out. So anyway, so you get into, so we're able to collect, based on current thermal energy harvesters, we're able to generate about 50 to 60 microwatts per square centimeter, which is actually pretty good in terms of making, we've demonstrated a full EKG patch that has, that's completely self-powered. Of course, then once you're generating that power, you have to then store that power, and then you have to trickle that power out as necessary. And that can be understanding that power management cycle, I think is a critical step, even if you're not even using energy harvesting, is a critical step to developing whatever wearable that you're going to make. So you can understand like things like lifetime and the uses for it. So yeah, hopefully that answers your question a little bit.
Got a question up here?
Specific to fibers. You talked sort of about fabrics and textiles, but are you also researching a new fiber, which has not really been introduced in a pretty long time?
So there's
maybe you could repeat the question or
yeah. So
summarize
the
it.
question was: are we looking at new fiber technologies? So there are a lot of, and I guess this is not necessarily have to do with electronics, okay, but in general.
When you integrate new electronics, are you thinking that you need new fibers that would integrate better than cotton or wool or even synthetics? Or are you looking at recycled fibers, things from plastics that maybe we're talking hard, electronics, maybe plastic or stuff?
Yeah, so are we looking at trying to replace cotton or nylon or with something that's recyclable? There's obviously a lot of work by a lot of companies that are out there making new types of synthetic fibers or even types of yarn constructions that offer very interesting mechanical properties. Like I know that really kind of recent technology that has been kind of picking up a little bit of steam are in auxetic structures, where they offer higher mechanical performances. You stretch it and it actually expands, which is kind of a weird concept. But anyways, there's lots of technologies like that are tracking parallel to whatever the electronics world's doing, and I'm sure that crossover point will end up happening at some point. But in terms of making a low-cost product, you're going to be making this on a polynylon or you're going to be making this on cotton. There's no doubt about it for the foreseeable future.
Other reactions? We talked about energy. We talked about fibers and fabrics. And I'm curious sort of how this plays into your own sense of what the state of the art looks like now or will look like in the near term in the space.
For me, discussion gives me a lot of faith that we're going to get there.
Yeah.
I've learned a lot about the activities at research institutions and DoD. We have probably a lot smaller programs at DHS and DoD. So we're always looking to kind of leverage or harvest, and I really like kind of how the conversation's going about the fibers and fabrics being a place where power and technology can meet. I think the only thing we probably didn't talk about is in today's world and with these emerging kind of tech environments, it's a great time though to think about hardening security in our initial designs instead of worrying about it on the back end like we're doing now with, say, your car.
Right. Well, that speaks to certainly speaks to us and the policy interest that we see coming up over and over again in emerging technologies around security and privacy and how you think about those issues early in the development cycle instead of later when it's often harder to deal with them.
Yeah, absolutely. So if you look at most of the products, people are making it for, or that are electronic garments. They're making it for health, fitness and wellness at this point, but they're not really making those health products. So for you to start collecting relevant health data, number one, it has to be relevant health data. And it also has to be data that is actually is meaningful. So it can't have a lot of noise or signal losses or signal noises that are occurring with it. But it's also got to go to a safe location. It's got to be stored there, and then it's got to be accessed by only the right people. And then, of course, you get into this whole big data type of problem where you have, so let's say you wanted to collect an electrocardiogram signal from me. So this is going to be a full wave electrocardiogram. You're also probably going to want to collect accelerometer data from different 3 axes. And then probably like a body temperature. That's going to be literally gigabytes of data every hour. That's a lot of data. And to visualize that data, a doctor couldn't possibly do it right now. So you have to look at like data visualization techniques and how to look for, these events that happen within data that would associate to a health event. And so that and then of course you want to be able to provide that feedback to the human as well. So again, looking at the Zephyr technology, they're going down that pathway of this visualization that's really kind of cool, and I really appreciate a lot of that.
I think we probably have time for one more, so why don't we do that right over here?
I'm sorry, could you expand on that? You mean as far as trade agreements, or?
If I have a product, and I believe if we are going to, I believe that we're going to be able to innovate and come up with all the perfect products for the application in the market. But when we want to try to sell those products, and markets outside the United States have got to go through customs and border control in other exportable countries who might not allow an electronic item on a textile to be accepted, or a border control agent stops it because they don't know if it's electronic, chemical, or is this a fabric labeled product. Have we got the shipping industry and the customs of different countries kind of involved a little bit at this point?
I think Alan, as the commerce guy, wants to answer that.
Yeah.
Gosh, I was going to say, I thought it was so great we had DHS here.
I know. Oh, boy. So the ask Eileen Hill a little bit later. When she's on the standards committee, she knows a lot more about this than anyone else in the room probably. So, but there are taxes on electronics and there's taxes on textiles. When you put those two things together, there's probably going to be strategies that you want to have towards shipping those things as a together unit and a not together unit. I forgot, man, who was it that tried to go through airport security with like a garment that had electronics all over it? It would not go well.
Well, and I will say this will be a perfect moment for me to turn this over to somebody who actually probably is thinking about this, which is our colleagues over at the International Trade Administration and Commerce. But before I do that, I just two quick things. One is we talk a lot about public-private partnership in this in investing in innovation and emerging technologies, just generally as a thematic. And this is a great. I think this panel is a great example of what we're talking about, and the fact that there is a public component to the public-private partnership, and we take it very seriously. And we've got some very thoughtful people here who've been thinking about it. So please join me in thanking our panel, and I'll turn it over to Josh then to bring us to lunch.
Thank you, Alan. Thank you, Dan. Thank you, Jess. Thank you, Steve. Really appreciate it. A great question, actually, because I believe we have customs staff in the audience today, so which is a great prompt for me to ask everybody to stretch, to make some connections with folks in the audience, and to do that just outside our doors while the Ronald Reagan building turns over our tables for lunch. We will resume our seats in a few minutes. Please pay attention to the chimes and go on and chat with each other about some of these questions. Thank you very much.
Well, the program on the